I'll try to be nice here after the Ben's talk. That was too funny, and for me to come up with this a bit serious talk would not be the nice way to go through it. And honestly, Ben has set a certain standard, to be honest, to what go with it. So here, we are actually talking about Jetpack Composer's Canvas. That's a tongue twister, to be honest, so I just named basic angle derivations, which one of my good friends, Nicole, showed yesterday, but we'll be going more in depth. So maybe it would be like a revision of how you do mathematics in your earlier school days. So that's what we are going to start off with, and I'm so sorry for taking you to the maths journey. I know it's hard. So before that, a basic introduction about me. I'm an Android engineer, obviously. I'm an open source contributor. I've been doing a lot of Jetpack Compose work for like couple of years now, and eventually I was one of the first GDEs for both Kotlin and Android in India. Now I located my base back to Berlin. Now, before the entire talk, I want to clear up few agendas which we are going to cover. There is something called Canvas 101. So for us, 101 basically means that we are going to see a samples rate, how paths and shapes, then the elementary school mathematics, some example, and few tips, miscellaneous examples, and something to go around with that. Now, before this talk, I always have this quote which I really like, that anyone can put a paint on the canvas, but the only true master can bring painting to the life. And honestly, trust me, I am very bad at painting. So this quote is just to make sure that we as engineers bring our code to life for people to use it generally. And that would be a funny way, or maybe a nice way to bring it on. But for painting, no, that's a dead end for me. Now, Canvas is a playground for us in Android engineering, honestly. But if you go to the technical definition, it's something else. But what I call it, for the last 1 year, 1.5 years, I have been exploring Canvas throughout, compare it to the view system or the Jetpack Compose, both of them. So for me, it has become a legit playground where I just go throw around something, some mathematical calculations, and come up with something. So a real descriptive explanation based on the documentation is a blank real estate that is used to draw something custom. What we basically mean by this, a blank real estate. And I'm telling you, this is not something from the developer's documentation. It's just a real estate. Consider it any phone, foldable, tablets. It's just a real estate for us. And we want to derive something out of it which is not already there. So it's like a real estate. Check anything, do anything, just make something work. Now, the bigger question here should be, why do we need Canvas? Because that's the bigger question. Because we have Canvas, not just in Android, but in a lot of different platforms. But there has to be a reason why we need Canvas. Because the amazing team at Google, they have been building a lot of components, coming up with a lot of solutions, composables, just to make our life easy. But when we talk about Canvas, the bigger point is that we still need to do a lot of work on ourselves, which we have to figure out, we have to draw. So why do we need it? The basic example is to see this. This is an example of one of the open source libraries. So this is a chart which you have to build, let's say, in your project. It can be, consider it in your open source project, in your job, or somewhere else where you need to design this. But do you think, is there anything which is pretty similar in composables? Is there it? Raise of hands if yes, in composables, or no? OK. Yes or no? OK, so the question is, do you think there is any composable by the Google team or from the composable Android X which has charts by default? No, right? At least what I think. So consider you need to replicate that. Honestly, we could have just said, oh, this is not there, we can just skip it. But sometimes designers be there. Oh, no, you have to do this. This is a design. It can be in iOS, it can be somewhere, but you have to do this. That is where Canvas comes into the picture. You have to draw something which is really custom, and then you need to bring it on. That's what we use Canvas for. So the basic, again, the theory book explanation is there is a limitation on design, what we can do from out-of-the-box composables. Or second is we need to draw something custom. It can be like this, a chart. And the third one is my favorite, exploring boundaries. You can literally go ahead and do whatever you want, wherever you want, and with whatever designs. For example, the third option can be explained with, if you see the dribble designs, you might like something. Just take it on, design it, and explore it. And at last, when doing that, you would be having a lot of fun. And I'm telling you that because a lot of trigonometry functions will come, and then at that point, you would be cursing yourself that you should have focused something on tan and cos. Something I do a lot. Now, for us, we do not have a canvas paper. Right? Now, going to this phone, if you see, this is the coordinate system, how our phone looks like. So for phone, you see the 4 coordinate blocks, A, B, C, and D, right? So that's how the coordinate system plots itself compared to the phone. Now, this is the center of the phone. I would not say center, but put whatever I could fit in. This looks like a center. Somebody wants to guess the center coordinates for this phone? Anyone, even left or the right, anyone works? Cool. So this would be the right one, 0 and y by 2, and x and y by 2, because it's in the half. Now, just to give the overview, this was more of a exercise just to see that how the whole coordinate system is being plotted, being divided, being sliced in half. Now, that's how we have learned about the center coordinates. Now we will see the composed canvas. I'm not going to touch anything around the view sample of canvas. Pretty much is the same thing what you can do with that, but here we'll be focusing more on composers canvas, more stress on that. Now, an implementation, if I have to put it that way. So it's just a generic composable function which you create. I named it as my canvas demo. And at that point, you can call the canvas composable with whatever modifier size you want. I have fill max size. And you can just go on, draw your designs, whatever you want, and whatever you want to plot it there. That's something you can do. The second way is you can use a box, and not just box, but any composable out of the box. And you can attach drop behind on the modifier itself. What this will do is, this is going to draw behind the base composable. So in our case, this is the box. So you draw something here in the on draw behind block. It will be drawn behind whatever there is inside the box, right? So a fun fact, the canvas composable actually looks like this. So there is a spacer composable in us, which just takes the modifier from the parameter and passes the on-draw scope, whatever we have there. So generally, what we saw here, the modifier draw behind, if you just move it with the spacer, that's an actual implementation of the canvas composable we saw here. So that's pretty much the similar thing. It's just that it's under the hood, which we do not explore it a lot. At least I don't. Sorry. Now, moving ahead. We'll discuss a certain sets of parts and shapes of what we are going to do here and what not we are going to do. So firstly, we'll see the draw line. For me in Canvas, draw line is pretty similar how we have hello world in any language. So if I have to start Canvas, I draw with draw line to learn something out of it. So for that, we have a function in the draw scope called draw line. There we have a couple of parameters. We'll go through it again. But it is inclusive in the draw scope lambda of the canvas. That's where we use it. Now, firstly, you use a drawLine function, which is a part of this canvas. Inside that, you use generally 3 parameters. The 3 parameter would be a color. It could be green. Then there's start. There's an end. So what the start and end basically means, where does the line start and where does it end, right? That's basic thing. Now, we have something called offsets. Offset you can consider as a data class or container which contains your x and the y coordinates on the phone. So here the start is 0, 0. Basically it starts from the top left and it ends into certain calculations, right? Which is derived from size.width and size.height. So size, now talking about that. Size basically comes from the composables draw scope. So when you create the canvas here, canvas gives you the size, basically the size that is being calculated using the parent modifier which it has. So here we are using the size of that and the width coming out of it, right? So that's how draw it. And when you draw this, this is the actual outcome, which we started from 0, 0 and ended on the center of the screen, right? Now, we have draw circles. Something, again, we are going to draw. And on the left-hand side, that's not the replica what we are going to draw. It's just the design. So in draw, we are going to use, again, a color. The color is green, and there's a center, right? What this center does is, if going back to our school days, we used to have a compass. We used to plot in between and just rotate it. That putting things in between is actually the center here. Now, here again, we have the offset. That offset is containing the size and the width, again, width and the height of it, and we plot that center there on the center of the phone. And when you draw that, that's a circle which comes out on the phone, how it looks like, based on whatever we had. Ignore the line behind, that's on the draw line. It was too much effort to remove that, so I just kept it on top of it. Now, there is one more parameter which you can do it, which you should, is radius. And you do not write that anything float. There is a value which you have to pass as a float value and not anything float. That didn't work or compile for me. So now, that were two different examples of draw line and draw circle. Eventually, we have draw rectangulars, the rect, draw image, draw arc, and draw point. Then these are the drawing of shapes. Then we have something called draw path, which you use to go around your canvas, have certain set of points, and draw around that. So now we'll see the draw path. You can see on the right-hand side of the code set, there is a path variable which contains a lot of path, and then we have certain move to, line to, we'll be explaining that, and just passing that path on the draw path. Now, just to go more in deep, this is path object which we created. Now on the left-hand side on the screen, you see a circle, the grayish circle. It would not be there. It's just for a visual representation. So in the path, when we go to move, it just brings our focus to that screen where we wanted it to be, in the center of the width with 0 y coordinate. And again, just to put things in fact, that circle would not be there. It's just for the focus. Now we are drawing a line from there to 0 and the height half. So when we go to the next line, this will draw a line. Again, we will draw another line to size, width, and height division by 2. That's the right side. And then we close it. So when you close it, this dashed line would again not be there. All I'm showing you is a visual representation. This would not be there. What it will do is, it will create a triangle, so wherever it started from, and whenever you close the path, wherever it started from and wherever the last point was moved, it generally goes there and creates a shape for you, basically using the 3 points which we used. And at last, we use that path, we put it in the path variable, draw path, and we pass on the color. This turns out to be an isosceles triangle, I don't know, a triangle. There's something there. Now, we got through the basics of circle, a line, and the draw path, correct? And we are going to use a certain of it. Draw path is pretty much useful when you draw something like charts. But now we are going to move a bit towards elementary mathematics. And before starting, I'm just saying sorry about that. So we'll be pretty much making this and a bit of tweaking there, but we'll be making a circular progress bar. And just so that you know this design is mine, there is the straight line behind that, which I couldn't remove. So we will be doing this circle progress bar. Now, I would be calling it as arc. If you go back to the previous slides where we had a couple of draw functions, at that point, we had a draw arc function as well, which we are going to use to draw inside the canvas composable, draw arc, right? So this is how the draw arc will look like. The color would be yellow. There would be a start angle, a sweep angle, a use center, a style. Again, I'll be explaining them, so no worries about that. That's something which I learned in the hard way. So we'll talk about start angle and the sweep angle. Start angle generally defines where does your composable drawing starts. right? The draw arc. It can be from the angles of 0, and the sweep angle means 360, right? Basically, what I mean to show you here is it covers the entire circle. And I'm assuming that a circle has 360 degrees in total, correct? Right. So we start from 0, we end at 360. So it's generally that saying that you just completed the 360 angle. So it's a complete circle which we completed, right? It just created an arc. Now, we saw the coordinate systems of the phone. Now this is the angle system of the phone, that the 0 starts on the right side, then on the bottom, it's just on the clockwise direction. It starts with the 90 degree, then we have the 180 degree, and there is this 270 degree, and then when we end it up, it comes up to the 360 again. So it's just basically that round circle which moves on the clockwise direction, right? The progress, which starts on that dashed which I have added on the circular progress, and it goes on from 90, 180, and 270. That's how you have done. So congratulations, you have drawn your design. Now, this is just a design which you have or which you can make pretty easily. Now consider this, not the right place to talk, but have you seen the Apple Watch UI where you have the progress bar, the circular progress bar of the fitness, where you increment the steps, correct? I cannot remember anything else, but that's a pretty common UI of a circular progress bar. So let's convert this into that design. It would not look the same, or else I would not be an Android engineer, but we would be covering this to 100 max value. So now we would not be using 360 as a hard-coded value. Rather than that, we would be taking a user's input, that what's the progress here on the progress bar, and how we are going to change the angles. Now, if you remember the sweep angle, which initially in the previous design was 360F, basically the 360 degrees. But here we want the progress values. And that progress value is going to come from the user's input, or let's say whatever we are calculating there. Let's say the steps of whatever you walk today, right? That could be here the progress value. So how does this progress value relate to your mathematical calculation, which relates to the 100 base, the progress max which we had here? 100 is the max value and 0 is the less, right? So considering this, we have a max progress of 100 bar. Then we will individually have an angle with the scale factor. So let's say we have 90 as the progress bar. We'll divide that and we'll calculate a certain mathematics. I'm not going to explain it here. But this max progress bar, it can be changed. For the easy explanatory purposes, this is 100 right now, and generally it's always 0 to 100. But it can be anything based on whatever you want to design. Now, the scale factor, what it does is, we have the total angles, 360 degrees, based on how much total progress we want. It's 100 here. So it would be 360 by 100 in this case, but it can be anything, whatever you decide on the max progress. And then we calculate the user progress input. Now, going back to the elementary mathematics again, this was, I think, in my class 3rd standard, which we were taught, 10 apples cost you 100. 1 apple will cost you 100 by 10. So 6 apple would be 10 into 6. That's the unitary method, right? That was pretty much what we were shown. 1 apple, 10, 60. Is this good enough for explanatory? But I'm so sorry, but I had to show you this. So the user progress input will become the input of the user into the scale factor. So the progress scale factor which we had, 360 by the max progress, right? Till this, we have actually had the progress inputs of whatever we wanted to click and whatever we wanted to show to the user based on whatever max progress was there, whatever the progress of user on stepping or something else was there. So this is what we have done, and now the hard-coded 360 is changed. Now this has changed to a different value which comes dynamically. Now, we learned about the static 0 to 360. We learned about the dynamic values. Now let's see if we have to make a clickable thing, or more like a drag thing, whatever. So like if I click something, it should progress to that angle. For that, we have something called detect tab gestures in the modifiers. So we use the pointer input, we detect tab gestures, And in that, we have a lot of different callbacks of press, double tap, long press, and on tap. But in this case, we are going to check on tap. We want to tap on that progress, and we want to call something or want to show something as like a thumb or something, right? So here, I'll show you this. This is a thumb, which I want to show on that specific position. Now, that specific position, again, going in the terms of mathematics, let's say this is x and a y. And the angle which we create from the base is angle A. So, again, going to basic mathematics, which Nicole said yesterday, the angle comes out from arc tan of y and the x. So the y you know is what was here. The x also you know, whatever you get based on tap of the modifiers. This one, you get the offset here of wherever you clicked. So you see the x and the y being there. So now the angles here are A tan 2, or in the layman terms, this is the inverse tan. This is, or the arc tan, whatever you want to call, but the functions are known as A tan 2 here, right? But this gives you the degrees in radians. And how we have been drawing till now in the circles is in degrees. So now another step for this to be calculated would be to convert this entire thing into radians, into degrees, the radians to degrees. So that difference comes up here. So the calculation is 180 degrees by pi, and whatever radians it came up with. So now you actually have the angle where you want to draw it. But now going back to the example of the draw circle, you remember draw circle cannot be drawn on an angle. It has to be calculated from a point, right? It needs a center. So there is a point to remember on that part, and we have to draw that thumb, that circular thing, draw circle, and it has to be drawn based on the angles we have, right? And till now, what we have an angle A, a progress input from user, let's say I am 50% out of 100 there, and what we need to calculate is the center of the thumb to draw the entire circle, or the thumb which we have, right? So the center, I'm just considering is 0 and 0. This is not. This is on the maths terms. This is the center. This is where we want to draw. This is the x and the y. So this would be, the x and the y coordinates would be radius into cos of the angle, comma, radius into sine of that angle. I'm not going to explain that. That was explained yesterday. Sorry, but if somebody missed it, go watch Nicole's talk. She explained in depth how was this working. I'll just give you how the basic representation of it looks like. So basically, in our mathematical terms, early in our days, we were explained, sine angles are basically the adjacent side by the hypotenuse, right? And the cos angles are basically the opposite side by the hypotenuse. So now if you go back to this example, you would see the exact same thing what we are trying to calculate. It's just that we are x and the y are the coordinates, and we have the radius, we have the angle. And the angle was calculated, just a previous one, this one. This was the angle, right? So now if I have to show you this, we have the radius of whatever we have to draw, we have the angles, and this is the basic representation how the angles actually work. So now the angle that we draw, x and a y, this is how it looks like. Radius into cos A, or cos alpha, whatever you can call it. The y would be r into sine A, and that's x or y coordinate. Now to draw that thumb, if you see there's a function which on the right, we have the circular color green, it can be white, whatever. But here the main thing to focus is the offset. The offset will take the x and the y coordinate, which we actually calculated right now with this cos A and a sine A. And again, I'm so sorry for this. Now, we are done with basic mathematical calculations, honestly, but there are a few things which I would like to share what we experienced while building a lot of Canvas things, that it's just not about the values and not about what you draw. It's about you need to scale this in all the designs, all the screens, and everywhere. Consider I built something for Pixel XL that does not work in Pixel 7. It does work, but it does not look nice. Or it could be on a tablet. It would not look nice. So how can you scale something which fits all the screens? So there are a few tips which we use. Use the percentage and the relative numbers. Do not hard-code a value, because 30 dp might look something very weird on a different screen, but might look something good in another screen. And when you're drawing something, let's say draw arc, or even the canvas in itself, it has to be relation to something like the size of the canvas or the box with the constraint size. It has to be in relation with the size we have. So what do I mean by that? Consider we have 2 canvases. This might not be the best performant enough thing, but this is just an example, so sorry for that again. So we have this size, and we are wrapping this both canvases inside box with constraint, which will have its own modifiers. But the best part about this is we can get the size from box with constraint. So consider this thing where we were scaling this design, right? Here, if we have to draw something, let's say in the canvas, we are drawing this circle, right? This thumb which we have. Now, do not think about angles, just the thumb. Here, you can get the canvas size from size.width, right? You can have the size, you can have the size.height. I'm just getting the width and assigning it to the canvas size. And now using that, I'm going to define the radius of that thumb on what should be the basic radius on which it has to be drawn, right? So here, the radius I am doing is canvas size divisible by 10. Now this is a proportionate value, so that in screens, canvas size can be different. If it's a larger screen, it's a smaller screen. So in that way, it will take this screen size and it will divide it by 10. Now it will have a proportionate value no matter what or which screen or which phone do you use. That's how you can scale it. Generally, we are not hard coding a radius here, but we are making it relation to the canvas size. Now, couple of miscellaneous things again, but it's not miscellaneous actually. So, canvas, just so that you know, Jetpack Compose canvas is not made literally like a new composable. It's made on the top of the view system's canvas. It's built on the top of it. So, if for any chance, if you have to access the native canvas, you have to use the draw context.canvas.native canvas. Do not ask me how did I get this, but I stumbled upon it. So you need to use this. Now, if you use a draw circle, draw line, or something like that, there is something called if you have to draw a text. Jetpack Compose canvas yet does not have a draw text as a function. So if you have to draw a text in your canvas, you need to actually pull out your native canvas, which is this, again, context.canvas.native canvas. And using that, you can draw a text on the canvas wherever you want to. Now, this is a very bad example, but this is an example how the text should look like and how you can use it. So here, first we are accessing the native canvas, the draw context.canvas.native canvas, or you can put it in alias, something like that, if you do not want to do it again and again. But this is how you use it. And inside that, you call the draw text function. And now, just to make things clear, this draw text is not coming out of Jetpack Compose. It's coming out of the view system's canvas. Inside that, I have 2 things, x and the y, where it starts. Again, it's the width by 2 and the height by 2, just to make it scalable and to a different size. And you use that to draw the text, right? Now, this paint object. This paint object actually takes color, size, and alignment, whatever you want to. It's basically like the customization, what you want to do, and you generate that paint here of how this text is going to look like. Consider, hey, Himanshu, but this is just another arbitrary text. But this is how you can use to draw the text. This, I don't know when the draw text is going to be in Jetpack Compose, but this is the way to access it. Now, we are almost at the end, but this is one of the bigger questions I was asked a couple of times, when not to use canvas. Because a lot of times, we actually justify why to use a canvas, where to use a canvas, but the bigger question should be when not to use it. So if given a chance, I would rather go berserk and I'll do everything in canvas. Maybe I'll create my own text composable with this, but I would not. I'm just saying. So again, things that are doable using the inbuilt composables, I would always prefer going with that because it has less drawing to do. It still uses the canvas in a certain aspect, but things which are built, which are inbuilt for you, you should always prefer to use that. Consider if you have to build a card-like design with an image with a text or something like that, do not think of using a custom design because it's not there by default and just use a canvas. No, you can rather compound couple of composables and make a design of whatever you can choose, right? So you do not have to be like a canvas drawer or like an Android canvas engineer in a specific person, right? Again, not to overcomplicate drawings like text, because text is like an inbuilt composable, a function which is being provided by the compose libraries, right? So if you just come up with a fancier idea that no, we are doing our design system, and rather than using a lot of things which can be used inbuilt, we would move ahead and just draw it everything on our own. Maybe just to increase the line of codes in our repository, I don't know, but it can be anything. So do not overcomplicate it and just use whatever is there. Drawing in the canvas, on my recommendation or my preference would be, should always be the last resort. If you see that's way too customizable or not provided or cannot be compounded, you should not, then you should use the canvas and not just jump onto that as the first solution. And with that, I think, thank you so much. All of the examples, whichever I have shown on the screen, is actually in this repository. It's highly built on Canvas, and it's Jetpack Compose enabled. Thank you.